Well, good day, everybody. I'm Russ Reed, and I'm the Executive Director of the National Center for the Biotechnology Workforce, located here at Forsyth Technical Community College in Winston-Salem, North Carolina. And hey, it's a happy New Year 2025, and I'm really excited. Trevor Tufano is with me. Trevor's our educational technician who puts these SciTechs together. Trevor, how are you doing?
I'm doing great, Russ. Thank you.
Well, Trevor, I'm excited because SciTech this year, we're going to focus on interviewing some of our local talent involved with regenerative medicine. And today we'll have a look at new technologies that'll help us train and educate people in some aspects of regenerative medicine. And I just want to welcome our guests, Mr. Josh Tan with Atrium Wake Forest Baptist, and Dr. Joshua Hunsberger, Chief Technology Officer at the RegenMed Development Organization, or called ReMDO. Welcome, guys.
Thanks for having us.
Great. Trevor, I'm going to turn it over to you. You've got some questions to ask.
Yeah. So, just to kind of kick things off, Josh Tan, could you maybe tell us a little bit about yourself? So maybe just where you work, what you do in your role, that sort of thing.
Yeah, great. Thanks, Russ, and thanks, Trevor. So happy to be here. I'm Josh Tan. I work at Atrium Health, Wake Forest Baptist, as Assistance Manager in the Department of Radiology. What do I do? That's actually kind of a hard question to answer. I'll give you a short answer, and then I'll probably give some more context. So I support and help out the research, the education, and the clinical side of the hospital, the School of Medicine, and also the Department of Radiology. My background, I'm a computer programmer that turned computer hardware expert, did a lot of databases and engineering. And then I came over to Wake Forest about 20 years ago. And back then, what we initially did was write algorithms for brain scans, using MRI scans and looking at lesions in brain scans and creating volumetric measurements. From there, we expanded into CT scans and 3D visualizations. And then we took those 3D visualizations and actually 3D printed them out. So this is actually a skull based off a CT scan. So pretty cool. So that same model we can now take into virtual and extended reality and also use that same model to do artificial intelligence. So essentially, I like to use technology from different domains and implement them in medical and healthcare. And we're also developing new hardware and software in the healthcare and medical domain. So that's a little bit of what I do on a daily basis.
That's awesome. Thank you so much for telling us about yourself, Josh Tan. Now, Josh Hunsberger, can you tell us some more about yourself as well?
Sure thing. So I wear multiple hats. One of those is Chief Technology Officer for a nonprofit called RegenMed Development Organization. ReMDO, which we like to call it rather than the full name. It essentially is looking to help accelerate RegenMed technologies in this incredible ecosystem in the Piedmont region of North Carolina. Another hat that I wear, I'm an executive director for Regenerative Medicine Manufacturing Society. It's a professional society bringing together stakeholders from industry, academia, government, nonprofits to really look at what are the challenges facing the field of regenerative medicine, in particular with a lens on manufacturing, and what are solutions that are being developed. And we have working groups in cell and biomaterial manufacturing, standards, quality control, 3D bioprinting, and AI and automation. And then the third hat, I'm part of the leadership team on the Piedmont Triad Regenerative Medicine Engine. And there I work on bringing new partners into this incredible ecosystem. And that engine is looking to essentially build a innovation hub in the Piedmont region of North Carolina focused on regenerative medicine and also building the next generation workforce. And the tie-in with virtual reality and some of the things that we'll talk about, that's going to be a major enabler that's going to reach into our ecosystem and help create sparks and collisions. Collisions, I love that word, in a positive context, that it will excite different communities within North Carolina and engage them in this incredible industry of regenerative medicine through awareness and education, but then also through collaboration, collaboration with universities and industry partners. So I'll stop there.
Hey, fine. That's excellent. Thank you both for telling us more about yourselves and also kind of about the industry that you're in. It's very interesting. All right. So for our next questions, I'm going to go ahead and turn it back over to Russ.
Hey, Trevor, thanks. And Josh, thanks so much. This is great. Really excited about this. Josh Tan, tell us a little bit more about how you're helping radiologists learn about radiology around the world, for around the globe, around the world. It's great.
Absolutely. Thanks, Russ. Great question. So we actually have multiple programs that we do. Some of them are traditional, Teams calls, Zoom calls, WebEx calls, all over the world. So we have these collaborations with Southeast Asia, South Asia, Africa, as well as South America, where we're presenting maybe once or twice a month with some of the radiologists around Wake Forest, Emory, MGH, Mayo Clinic, and Stanford, where we're actually giving these real-time presentations of cutting-edge radiology, expertise on these calls. So that's one aspect of it. The more exciting aspect that I have, I think, is using virtual reality. So, we have headsets like the Apple Vision Pro. We have an HTC XR Elite headset, as well as the Meta Quest 3. We're using these guys to actually jump into a collaborative session. And so there's a company out of Canada that we're partnering with called Luxonic, and essentially they make a virtual radiology viewing room. So you put on the headset and you're transformed into a radiology reading room. Typical radiology reading workstations, viewing workstations, they're between $20,000 to $40,000 per piece per workstation, and you have to go to a physical place, an office, a cubicle, a viewing room. And so with a virtual reality headset, you could be portable, and so you could be anywhere. But I guess the more exciting part of it, and I'm going to try to share my screen in a second here, but essentially this app that Luxonic has made is one of those that, sorry here, let me see if I can get this working. All right, let's see if we can get this to play here. But essentially, you're joining a virtual reality viewing room. So instead of playing, one of these virtual reality games, we're playing a virtual reality viewing room where up here in the right, we have a guy in Canada. I'm here in Winston-Salem, North Carolina. Mike is in Saskatoon, Canada, and Dr. Burdette is in Ecuador. And so we're literally looking at images of this brain with a brain tumor in real time. So we're each in different locations with audio and avatars, as well as virtual laser pointers in different colors. And so the beauty of that is, we could all fly into one location and point at the screen, or we could do this in virtual reality anywhere in the world with internet connectivity and have synced images and audio, video, and virtual laser pointers. So that's one way we're working with virtual reality in the medical domain.
Wow, Josh Tan, that is awesome. That's really, Trevor, what do you think of that as
That's
technician?
really, really cool technology to kind of see that like in demonstration. That's really awesome.
Yeah, that's great. So, Josh Hunsberger, how do you see this technology that Josh Tan is doing in the virtual and augmented reality affecting the area of regenerative medicine?
That is an excellent question. So it can hit multiple areas. So one can be in the area of education and training and bringing, so you can imagine that virtual room, we could create a digital twin of a manufacturing facility. And so we could then use that digital twin of that manufacturing facility and share that to communities all across North Carolina, all over the nation, all over the world. So they're now gaining access to these advanced technologies that we're working on, 3D bioprinters, for instance. In addition to education and training, it could also be a great collaboration tool. So you could imagine companies coming together and sharing their technologies. And again, in that room that Josh showed you, where they're looking at these radiology images, you could then have each of your technologies where you're trying to problem solve maybe a manufacturing challenge, or you're developing a manufacturing workflow and a quality control and optimization strategy. All of that could be done in that virtual environment. So I see so many use cases for this, and it's really going to help, I think, translate the technology to that they're going to gain a sense of, oh wow, this is amazing technology. I want to learn more about it. I want to, go to maybe a course, a summer training course, and learn more about 3D bioprinting and tissue engineering. We're even thinking of all sorts of other applications too. Like, could you imagine this brave new frontier of in-space biomanufacturing, where astronauts could train on this type of device, where they would simulate doing biological experiments up on the International Space Station? So it's a pretty exciting technology that I think is going to have a great impact in this region, both in terms of education, outreach, and collaboration.
Trevor, I don't know about you, but I got a lot of adrenaline pumped in me right now. And I'm super excited about this, but I just wanted, before I turn it over to you, Trevor, I just wanted to tell you that what Josh has just said, what the two Joshes has just said, is actually a reality now. It's starting to be a reality here at the college, in that we've contracted to do virtual reality of a new bioprinting system that we have here at the college, and everything that the two Joshes has said or demonstrated are going to become a reality here. So we're very excited about it. And now I'm going to turn it back to you, Trevor. Thank you, both Joshes. Thank you.
Yeah, thank you. But that is definitely very exciting that we had that partnership at the college and that kind of technology. It's very, very cool. So Josh Tan, could you tell us some more about sort of the direction that we're heading with these technologies?
Absolutely. So I'm just going to pull up one of my headsets here. This is an Apple Vision Pro. This is a $3,500 device. And I actually went out to Apple in October 23 and got to preview this at Apple headquarters. It's pretty cool before it was publicly released. And we developed an app, a demo app, and we went out there to test it with Apple engineers and designers. And it was really cool. This piece of hardware is essentially a laptop, a MacBook Pro kind of strapped to your head. It has 14 cameras, 6 microphones. It's got a retinal scanner. It has a Dolby Atmos built in. And the screens are roughly 4,000 to 5,000 pixels per inch. And so a lot of this technology is very, very expensive because the resolution, the refresh rate, all of these sensors that are built in, it's just an amazing piece of equipment. Hopefully in the near future, prices will come down. The different vendors are coming up with different technologies that will try to match the Vision Pro. And so because of that, just like the smartphone industry, I think the immersive space, VR, XR, AR, and MR, all those domains will get better, right? The more competition you have, the better the hardware will get. But I think we have to get better software and apps and use cases. And those are the things that are going to drive the hardware as well as the software. So, there's all sorts of really cool sensors that are coming out. I just got this camera. This is a 360 immersive camera. It's 8K. So it's an 8K 360 camera. And so we're going to start working on this with Josh Hunsberger as well as Russ to start doing some kind of hybrid, learning, education, and training simulations with video. The beauty of the 360 is that when you put on an immersive headset, you now just look around instead of having to shift through your mobile device or your web page. So when you're actually in VR or AR or MR, you actually just look around. So it's actually a pretty cool concept. We have some hybrid other components that we're working on, but eventually we want to make it all, virtual augmented, extended. So you're actually in real time in a virtual space learning how to run a 3D bioprinter, right? Or you're training somebody how to run a microscope. And so there's all sorts of really cool things that you can think about, right? You can actually jump into a digital twin, let's say of the ISS or of the test bed or of a lab at Forsyth Tech. And you could do it remotely with a $300 headset. So some of the newer Quest headsets are around $300. And we could jump into a virtual, Forsyth Tech lab with equipment that actually works. So we need programmers that can design these digital twins along with this 3D model of, let's say, a bioprinter that actually works. So you start typing on the laptop that controls the virtual laptop that controls the virtual 3D bioprinter, and you have to load in cells. You have to load in a structure. You have to load in supports. All this stuff can be done, virtually. Instead of spending thousands of dollars, if you break this piece of equipment, you can do it virtually and practice many, many times. So I think all the hardware, the software, the use cases, when those get more well-defined, the software that you design content, when that gets easier. So almost like PowerPoint. Before PowerPoint, it was pretty difficult to create PowerPoint, presentations. And now PowerPoint's used probably billions of times. And so that's what we need to get to be able to create content very quickly. That's virtual as well as 360 video, and combine it with the right use cases and the right collaborators. So I think that's kind of where we're headed in the short term and the long term.
That's great. Thank you, Josh Chan. I think it's definitely really exciting to kind of see the direction that all these different technologies are going to go in the near future. So and long term as well. So definitely thank you. Russ, for our next question, I'll go ahead and toss it back to you again.
Hey, Trevor, thank you. Okay, this is when we put these guys into the afterburner. So to Josh Hunsberger, what are your thoughts? Josh, you and I have had many discussions with Josh Tan regarding these, and with all the colleagues that Josh Tan and you are specifically working with. Sometimes I feel I've been blasted into another world. So I just want you to give us some of those thoughts in your head. Where's all this going? And I think also Josh Hunsberger and Josh Tan, it might be great to relate it back to the engine, and more specifically, if you can, relate it back to what you think this looks like for the workforce. I think Josh Tan just touched on it briefly, but this would be great. This is your time. Go for it.
Yeah. And Josh, let's tag team back and forth. So I guess where I want to start is what I see for our ecosystem is companies can build digital twins of their manufacturing process, and they can then come into our ecosystem with these digital twins. We can help them to optimize those manufacturing processes. And what that will essentially enable companies to do is have more efficient, effective ways and processes developed that are going to allow them to manufacture RegenMed products better, cheaper, faster. With that process, you can also layer in that training component. And what better way would be to be able to put on that VR headset and have technicians learning about building a tissue or organ, or going through a cell manufacturing process and expanding to billions and billions of cells, or 3D bioprinting scaffolds. All of these amazing technologies and processes that are moving forward towards developing clinical products. So you could then develop these training programs. So you really are having hands-on training in a translational sense. I have a far out topic that I want to throw out there, but I'm going to hold on to that for a little bit. I'll kick it over to you, Josh.
Yeah, that's great, Josh Hunsberger. So one thought that just popped into my head is, right, the Vision Pro, it's like an Apple device. So I actually, when I jump into that, I can see things floating in midair. And so essentially it has eye trackers, and it tracks your eyes. So that's actually how you navigate. And then you kind of tap and you hold and you move, kind of like a left click. And so the really cool thing is you can have a heart floating in midair. And if Josh Hunsberger and Russ and Trevor have Vision Pros, you actually are seeing it from your view. So kind of like the skull. If I'm over here, I see it from the back, but you guys see it from the front. And when I rotate this, it actually updates in real time on all of our displays. So one of the things that I've done so far is actually connected a wireless handheld ultrasound machine to my Vision Pro and broadcast that to somebody else at another location. So we could use that for training and education in real time, which is pretty cool. So just think about the ramifications, right? We can start to have an expert teach, or we could actually evaluate somebody on their skills. So we have training sessions for MRI and CT scans that are starting to come up, along with ultrasound and fluoroscopy and mammography. So you can train, you can actually test them before you hire them. So there's all sorts of opportunities. I think one of the other things that I just wanted to mention real quick is we also need infrastructure like Wi-Fi and cellular capabilities. So that internet connectivity has got to get better and faster. And so one day, Josh Hunsberger, I mean, it would be amazing if we could control 3D printed printers on the ISS down here from Earth. But that connectivity has to be faster. So I mean, we could literally have a 3D camera up on the ISS, and we could go around and do things on the ISS while on Earth. So Josh Hunsberger, back to you.
So since you brought back that space component, I'll go where I wanted to go, but I wasn't quite ready to jump to that level. So the future is, and let me start by saying, in space manufacturing, that is going to be just another lab space that everyone has access to in the future. It's going to be a transformational technology that people are going to be able to develop advanced materials that you can't develop anywhere else. There's going to be studying disease models where you can get accelerated disease indications, like in cancer, for instance, is one area where they're seeing more aggressive cancers in microgravity environment, that you might be able to then unlock new signaling pathways and new potential targets. But also up there, they're going to be biomanufacturing new therapies. And a question that's going to come up is, what about the FDA and the regulatory? Well, VR can basically address that. You could have then remote inspections of ISS national labs or any commercial provider. There's commercial space stations being built now, so they could then be able to do those evaluations through virtual reality, where they're then transported up and seeing those manufacturing processes. And likewise, it could be a great collaboration tool as well, where you bring together leading experts in different areas and say, hey, here's a phenomenon that we are experiencing in microgravity. We think it's really exciting. We don't quite know what the potential is commercially, but let's bring all of these great leaders and experts together. That could also be where we're looking at for the future. So I think that's a pretty exciting direction, and it's not as far away as you might think. So passing it back to you, Josh or Russ.
Well, you guys know that I'm really excited about this, and I'm excited about your work. And you're both working in different areas, but both are going to have tremendous impact on medicine, on patient care, and ultimately, if things can be done in a microgravity situation that can't be done here on Earth, and we can somehow, some way also benefit by being able to train people. My gosh, that's just so exciting. And imagine, Trevor, as you being a graduate of Forsyth Tech, can you imagine that across the street, these two people are literally across the street working in their institutions, right? Doing this, and are already connected with, as Josh showed, around the world. But at the same time, Josh Hunsberger said, with the ISS, with the space station. And so, this is the opportunity for our students going forward. It's Josh Tan, Josh Hunsberger. Are we talking technicians, or are we always talking about engineers, scientists? What are we talking about in terms of the kinds of skills and people that you'll need to see in the future workforce that isn't that far away?
Josh, you want me to go? Okay. So, I think it's going to be a variety of different skill sets. First, I'll say the skills that folks are learning, such as aseptic cell culture techniques, those are going to translate into what's being done in space biomanufacturing. Those same skills and manufacturing processes, there's going to be a lot of processes that are just transferred up. Where I think there are going to be some disruptive technologies, I'm going to bring in AI and machine learning into this. So the two Nobel Prizes in 2024 for chemistry and physics were both based off of key insights from using artificial intelligence. And that is going to continue to disrupt regenerative medicine in basically every single field out there, where we're going to be able to apply these digital twins, machine learning, advanced analytics. For instance, I'll give an example for clinical trials. So the future is developing these body-on-a-chip technologies where you can create miniaturized organ systems and connect them together, and on a personalized level, be able to evaluate drug safety and efficacy. Well, imagine if you take all of that data and build a digital twin of it. That's where we're headed for the future, where we could then genotype people, and then with enough data, I think we would get to a point where we could predict drug responses for patients based off of the use of these digital twins. So in terms of another skill set, being able to understand how to use these data platforms, being able to think about already established databases that we might have access to, like repositories from the National Institutes of Health. So I think that will also come into play in the future. Off to you, Justin.
All right. So Russ, I think we've kind of gone around the circle and come back. There's all sorts of, I guess, jobs and skill sets that are needed, right? We need the community college level, the associate's degree. We need the bachelor's. We need the master's, as well as the postdoctoral and the MD, right? We need MBAs. We need all sorts of things. Just touching back with Josh Hunsberger, right? AI, right? Python. We need Python programmers. We need specialized Python programmers for the healthcare field. They're very hard to find. So a lot of times we look for an IT programmer, IT person that can also program, and we can teach them about medical. The medical imaging domain is very, very different than other parts of the hospital. A lot of AI there are large language models, or we're looking at actual pixel values. We'll have CT scans with stacks of images, 3D, 4D, and 5D. Sometimes we have multiple different domains. So we have CT, MRI, and PET scans. And then we also have them over time. So that's where you have the different dimensions of time and different dimensions of data. And so we're actually working on, how if we can predict cancer with imaging. It's actually pretty fascinating. And it relates to regenerative medicine, because a lot of times we want to do MRI and CT scans, but we also need to do micro CT and micro MRI scans all the way down to the cell level. Can we include all that data so that when you're taking an MRI scan, that you can actually use that trained model based off the cellular data to predict something. So we're going to need these programmers. We not necessarily need a PhD programmer to do all of the work, right? Maybe we just need an associate's Python programmer that we've trained specifically for neuroradiology. There's that. We need video editors. We need game developers. And then we also obviously need all the different levels here and in between in all the domains. And that's one of the things I think I find fascinating, right? How do we bring different domains together? And I think between Russ and Josh Hunsberger, we just cross so many different domains, but that overlap of those domains is where the power comes into play.
Well, this has been very exciting, and it is a series, right? So SciTech is a series, Trevor. We love it when we get a topic and we can take it to the next level. And you guys have done a fantastic job today. So I want to thank you on behalf of Forsyth Tech. I want to thank you on behalf of the NSF Piedmont Triad Regenerative Medicine Engine as well, and also for your respective institutions, Atrium Health and also ReMDO. So Trevor, any last comments?
Just wanted to say definitely really, really cool technology and just kind of insights on the whole field that y'all are talking about. And just, it's really, like I said earlier, it's just really exciting to kind of see, all the different applications and potential applications that, this technology can be used for. And yeah, just really, really cool stuff.
Thanks. We agree.
Thank you, guys.
All right. Thanks.
Thanks, Trevor.